Hi students, today we are going to discuss about two commonly used sampling distributions, students T distribution and F distribution. First, let us consider the students T distribution. This distribution was introduced by William S. Gossett. The probability density function of students T distribution is f of t is equal to gamma n plus 1 by 2 divided by gamma 1 by 2 into gamma n by 2 root n into 1 plus t square by n raised to minus of n plus 1 by 2, where t is from minus infinity to infinity. This is denoted as t follows, that is the random variable t follows t with n degrees of freedom. Since it is a sampling distribution, we consider this as the distribution of a statistic, and here t is denoted as the statistic. Next, let us consider a statistic whose distribution follows students T distribution. If Z follows n01, that is standard normal distribution, and y follows chi-square n, a chi-square distribution with n degrees of freedom, and if these two random variables z and y are independent, we consider the statistic t is equal to z divided by root of y by n, or it is same as z divided by root of chi-square n by n. The distribution of this statistic is called students T distribution. With n degrees of freedom, that is it follows T distribution with n degrees of freedom. To derive the students T distribution, we consider the joint density of the random variables z and chi-square. So, the joint density of z and chi-square is f of z comma chi-square is equal to f of z into f of chi-square. Since these two random variables are independent, the joint density can be written as the product of the marginal densities. Then we consider the transformation t is equal to z by root of y by n and u is equal to chi-square n. We have to find out the distribution of t. From this, we can write z as z is equal to t into root of y by n. It means this is equal to t into root of chi-square n by n, or that is same as t into root of u by n. Now, since we have transformed z and chi-square to t and u, we have to write the density f of z chi-square in terms of t and u. So, f of z chi-square is equal to f of z into f of chi-square, that is 1 by root 2 pi e raised to minus z square by 2 into the density of chi-square, that is 1 by 2 to the power n by 2 divided by gamma n by 2 e raised to minus chi square by 2 chi square raised to n by 2 minus 1. Now, we can write f of t u as 1 by root 2 pi e raised to minus, in the place of z you have to write t root u by n, and also in the place of chi square you have to use u. Therefore, this is e raised to minus t root u by n the whole square by 2 into 1 by 2 to the power n by 2 divided by gamma n by 2 e raised to minus u by 2 u raised to n by 2 minus 1 into Jacobian of transformation J is equal to determinant of partial derivative of z with respect to t, partial derivative of z with respect to u, partial derivative of chi square with respect to t, partial derivative of chi square with respect to u. Z is equal to t root u by n. So, when we find the partial derivative of z with respect to t, we get root of u by n, and similarly partial derivative of z with respect to u will give you t by root n into 1 by 2 root u. This is equal to determinant of partial derivative of z with respect to t, it is root of u by n, partial derivative of z with respect to u, and it is 1 by root n into 1 by 2 root u, partial derivative of chi square with respect to t, it is equal to 0, partial derivative of chi square with respect to u is 1, and this determinant is equal to root of u by n. So, substituting this in the density function, joint density of t comma u, that is f of t u, we have f of t u is equal to f of t comma u is equal to, this is equal to 1 by 2 to the power n by 2 root 2 pi gamma n by 2 e raised to minus u by 2 into 1 plus t square by n u raised to n by 2 plus 1 by 2, that is n plus 1 by 2 minus 1 into 1 by root n. So, into 1 by root n. Now, we have to find out the distribution of t. So, the marginal density of t is f of t is obtained by integrating this joint density with respect to u. So, f of t is equal to 1 by 2 raised to n by 2 divided by root 2 pi gamma n by 2 root n e raised to minus u by 2 1 plus t square by n u raised to n plus 1 by 2 minus 1 integral of this one with respect to u means it is from 0 to infinity du. Now, that is equal to (1 by 2 to the power n by 2) divided by root 2 pi gamma n by 2 into root n gamma n by 2 into root n. Then this part integral 0 to infinity e raised to minus u by 2 1 plus t square by n into u raised to n plus 1 by 2 minus 1 du, which is of the form integral 0 to infinity e raised to minus mx x raised to p minus 1 dx is equal to gamma p by m raised to p. So, in the place of p we have n plus 1 by 2, in the place of m we have 1 by 2 into 1 plus t square by n. So, the integral is gamma n plus 1 by 2 divided by 1 plus t square by n into 1 by 2 the whole raised to n plus 1 by 2. That is equal to, simplifying this we get 1 by 2 to the power n by 2 divided by root 2 pi gamma n by 2 root n gamma n plus 1 by 2, and this is 1 by 2 to the power n plus 1 by 2 into 1 plus t square by n to the power n plus 1 by 2. That is equal to, here we have 1 by 2 to the power 1 by 2, and 1 by 2 raised to n by 2 is here, here also you have 1 by 2 raised to n by 2, these two terms are cancelled. So, remaining terms are gamma n plus 1 by 2 in the numerator, and the denominator we have root 2 pi gamma n by 2 root n, here you have 1 by 2 to the power 1 by 2 into 1 by 1 plus t square by n to the power n plus 1 by 2, and this root 2 and this root 2 is cancelled, and finally we get f of t is equal to gamma n plus 1 by 2 divided by root pi into gamma n by 2 into root n, root pi gamma n by 2 into root n into 1 by 1 plus t square by n raised to n plus 1 by 2. This can be also written as 1 by root n into beta 1 by 2 n by 2, since beta 1 by 2 n by 2 is gamma 1 by 2 into gamma n by 2 divided by gamma n plus 1 by 2. So, this is same as this term into 1 plus t square by n raised to n plus 1 by 2, and this is the density function of the student's t distribution, where t is from minus infinity to infinity. Now, we can find the mean and variance of the t distribution using our elementary method. The odd order moments of t distributions are zeros, and even order moments are given as mu 2 r dash is equal to n raised to r into 2 r minus 1 into 2 r minus 3 etc. 3 into 1 divided by n minus 2 into n minus 4 etc. n minus 2 r if n by 2 is greater than r. So, these are the even order moments, and mu 2 r plus 1 dash, as I already said, these are equal to 0. Hence, variance can be calculated as, it is mu 2 dash minus mu 1 dash square, it is equal to n by n minus 2 if n is greater than 2. Now, let us come to the sampling distribution called F distribution. We first define the distribution and then explain the method of deriving the same. If chi1 square and chi2 square are two independent chi-square variates with n1 and n2 degrees of freedom respectively, then we define a statistic f is equal to chi1 square by n1 divided by chi2 square by n2, where these two random variables are chi1 square and chi2 square are independent. Then the distribution of f is denoted as f distribution with n1 n2 degrees of freedom, and the density function can be written as f is equal to n1 by n2 raised to n1 by 2 divided by beta n1 by 2 comma n2 by 2 into f raised to n1 by 2 minus 1 divided by 1 plus n1 by n2 f raised to n1 plus n2 by 2. Since it is the ratio of two independent chi-square variates each divided by its degrees of freedom, the range is 0 less than f less than infinity. Derivation of the f distribution can also be done using a suitable transformation. We can consider the joint density of chi1 square and chi2 square, and it is f of chi1 square comma chi2 square is equal to f of chi1 square into f of chi2 square, since these two are independent observations. Now consider the transformation f is equal to chi1 square by n1 divided by chi2 square by n2, and also define or use the transformation u is equal to chi2 square. We have to again find the distribution of f. From this we can see that chi1 square can be written as chi1 square is equal to f into chi2 square by n2 into this n1. So, chi1 square is f into chi2 square by n2 into n1, and again chi2 square is u. Here also we consider the Jacobian of transformation, and we get the Jacobian of transformation as n1 u divided by n2. Then the joint density of f of chi1 square chi2 square is f of chi1 square into f of chi2 square is equal to 1 by 2 raised to n1 by 2 divided by gamma n1 by 2 e raised to minus chi1 square by 2 chi1 square raised to n1 by 2 minus 1 into 1 by 2 raised to n2 by 2 divided by gamma n2 by 2 e raised to minus chi2 square by 2 chi2 square raised to n2 by 2 minus 1. This is equal to k into e raised to minus chi1 square plus chi2 square by 2 chi1 square raised to n1 by 2 minus 1 chi2 square raised to n2 by 2 minus 1, where k is equal to 1 by 2 raised to n1 by 2 into 1 by 2 raised to n2 by 2 divided by gamma n1 by 2 into gamma n2 by 2. Now, the joint density of Fu is equal to the density of chi1 square chi2 square into Jacobian, and hence it is equal to constant k into e raised to minus chi1 square plus chi2 square by 2, that is e raised to minus chi1 square is n1 by n2 f into u, chi2 square is u. So, e raised to minus chi1 square plus chi2 square by 2, then chi1 square raised to n1 by 2 minus 1 into chi2 square raised to n2 by 2 minus 1, that is chi1 square raised to n1 by n2 f u raised to n1 by 2 minus 1 chi2 square, that is u raised to n2 by 2 minus 1 into Jacobian of transformation. Jacobian of transformation is n1 u by n2, that is equal to k into n1 by n2 raised to n1 by 2 minus 1 f raised to n1 by 2 minus 1, then this term is e raised to minus u by 2 into n1 by n2 f plus 1. Here we have u raised to n1 by 2 minus 1 plus n2 by 2 minus 1 plus 1. So, n1 plus n2 by 2 minus 1, and here also we have one n1 by n2. So, this is n1 by n2, and this is equal to our k is equal to k is equal to 1 by 2 raised to n1 by 2 into 1 by 2 raised to n2 by 2 divided by gamma n1 by 2 into gamma n2 by 2. So, this is equal to 1 by 2 raised to n1 by 2 into 1 by 2 raised to n2 by 2 divided by gamma n1 by 2 into gamma n2 by 2, n1 by n2 raised to n1 by 2 minus 1 and n1 by n2. So, we have n1 by n2 raised to n1 by 2. Then this is f raised to n1 by 2 minus 1 e raised to minus u by 2 into 1 plus n1 by n2 f into u raised to n1 plus n2 by 2 minus 1. This is the joint density of f comma u. Now, we have to find out the marginal density of f. Therefore, the marginal density of f is equal to integral 0 to infinity f of f comma u du, and that is equal to 1 by 2 raised to n1 by 2, 1 by 2 raised to n2 by 2 divided by gamma n1 by 2, gamma n2 by 2, n1 by n2 raised to n1 by 2, n1 by n2 raised to n1 by 2 into f raised to n1 by 2 minus 1 integral 0 to infinity this term, that is e raised to minus u by 2 into e raised to minus u by 2 into 1 plus n 1 by n 2 f into u raised to n 1 plus n 2 by 2 minus 1 du, and that is equal to 1 by 2 raised to n 1 by 2, 1 by 2 raised to n 2 by 2 divided by gamma n 1 by 2, gamma n 2 by 2, n 1 by n 2 raised to n 1 by 2, f raised to n 1 by 2 minus 1 into, using the definition of gamma density is gamma n 1 plus n 2 by 2 divided by 1 by 2 into 1 plus n 1 by n 2 f raised to n 1 plus n 2 divided by 2. Here we have 1 by 2 raised to n 1 by 2 into 1 by 2 raised to n 2 by 2. Here also we have 1 by 2 raised to n 1 by 2 into 1 by 2 raised to n 2 by 2. So, those two terms are cancelled, and finally, we get the marginal density of f as f is equal to n 1 by n 2 raised to n 1 by 2 divided by gamma n 1 by 2 into gamma n 2 by 2. The numerator we have gamma n 1 plus n 2 by 2. So, it is gamma n 1 plus n 2 by 2, gamma n 1 by 2 into gamma n 2 by 2 into 1 plus n 1 by n 2 f raised to n 1 plus n 2 by 2. So, 1 by 1 plus n 1 by n 2 f raised to n 1 plus n 2 by 2, which can also be written in the form n 1 by n 2 raised to n 1 by 2 divided by beta n 1 by 2 n 2 by 2 into, I think here one term is missing, it is f raised to n 1 by 2 minus 1. So, here we have f raised to n 1 by 2 minus 1. So, it is f raised to n 1 by 2 minus 1 divided by 1 plus n 1 by n 2 f raised to n 1 plus n 2 by 2. And this is the density function of the f distribution, and we know that here we have 0 less than f less than infinity. The mean and variance of the f distribution can easily be derived, and mean is equal to n 2 by n 2 minus 2 if n 2 greater than 2, and variance is equal to 2 n 2 square into n 1 plus n 2 minus 2 divided by n 1 into n 2 minus 2 whole square into n 2 minus 4 if n 2 greater than 4. So, we have discussed about the important sampling distributions, their properties, and it is time to conclude this session. Thank you very much.